Welcome to the video lecture series. In this session, I will be explaining how to classify the soil based on the HRB soil classification system. First, we need to understand what is the purpose of classifying the soil. Different type of soils are available in the nature. Here, the classification system will help you identifying the right type of soil for the right usage. Here we have different type of soil classification system. In that we have textural soil classification, unified soil classification, highway research board classification and IS soil classification systems. In today's session, I will be explaining how to classify the soil based on the highway research board classification system. This is the highway classification, HRB classification of soil and soil aggregate mixture. Here, the soil is classified into several groups starting from A1 to A7, where A1, A2, A3 are considered as the granular soils, A4, A5, A6 and A7 are considered as the silty, clay and mixtures, where the percentage of soil which is passing 75 micron is more than 35% and granular material is one where the percentage passing 75 micron is less than 35%. Here in this classification system, we use the sieve analysis data and the plasticity characteristics for classifying the soil into different groups. As I told you, in HRB classification method, we are classifying the soil into 7 groups starting from A1 to A7, and A1 here is further classified into 2 subgroups, that is A1A and A1B, and A2 into 4 groups, that is A24, A25, A26 and A27, and a characteristic group index is used for classifying the soil within the group, and the data required for classifying the soil based on the HRB system is the grain size analysis data, that is the particle size distribution data which is obtained by conducting the sieve analysis to the soil. The second thing is liquid limit, plastic limit, plasticity index. These things are considered as the index properties of the soil. By conducting tests, we will come to know what is the liquid limit, what is the plastic limit of a soil, and the plasticity index is the numerical difference between the liquid limit and the plastic limit, which can be calculated easily. As I told you, the consistency limits, we need to understand what this liquid limit, plastic limit is before proceeding into the classification system. Liquid limit is the minimum water content at which the soil will flow under the application of very little shear force. The Casagrande apparatus is used for determination of liquid limit, and this liquid limit plays a very important role in classifying the soil, especially in HRB system of classification. Then again, the plastic limit is the minimum water content at which the soil remains in plastic state. Plasticity index is the numerical difference between the liquid limit and the plastic limit. We use liquid limit, plastic limit and plasticity index along with the grain size analysis data for classifying the soil in the HRB system of classification. Now, coming to the group index is given as 0.2 A plus 0.05 AC plus 0.01 BD. Here we need to understand what is this A, B, C and D, that is very important in calculation of the group index of a soil. And group index is used for classifying the soil which falls under the same group, that I will explain later. Here A is that portion of material which is passing 75 micron and which is greater than 35 and not exceeding 75, which is expressed as a whole number between 0 to 40. Say for example, if the percentage passing 75 micron is 50, then the value of A will be given as 15. Why? Because we are expressing it as a whole number between 0 to 40. If we are getting the value as 35, then the value of A will be 0. If we are getting the percentage passing 75 micron as 75, then the value of A will be 40. Therefore, the value of A is calculated like this. If the percentage passing is 50, then that 50 minus the lower limit, that is 35, which will give you the value of A. And the value of B will be like this, that portion of material passing 75 micron ISC, which is greater than 15 and not exceeding 35, which is expressed as a whole number between 0 to 20. Again, same thing, if the percentage passing 75 micron is 15, then the value of B will be equal to 0. If the percentage passing 75 micron is equal to 35, then the value of B will be equal to 20. Anywhere in between is to be expressed between the whole numbers 0 to 20. And C is that value of liquid limit in excess of 40 and less than 60. Once again, if the liquid limit of a soil is 50, then the value of C will be equal to 10. If the liquid limit of the soil is equal to 60, then the value of C will be equal to 20. And D is the value of plasticity index, which is exceeding 10 and not more than 30, which is expressed as a whole number between 0 to 20. Once again the same thing, if the plasticity index is equal to 10, then the value of D will be equal to 0. If it is equal to 30, then the value of D will be equal to 20. And this is how we are calculating the group index, and this group index will help us in classifying the soil which falls under the same group. Now, let us proceed towards how to classify the soil using the HRB soil classification chart. The procedure will be like this. Always we need to proceed from the left towards the right of a chart. The correct group is identified by the process of elimination. The first group from the left into which the test data will fit will be corrected as a classification, and group index is used to classify the fine grained soil in the same group. In this chart you can see, if the percentage passing sieve analysis data is there, that is a group classification sieve analysis data, and once we know what is the percentage passing 75 micron, and we have to proceed from the left towards the right. Say for example, if the percentage passing 75 micron is 30, in A1 we can see 15 is maximum, in A1B 25 is maximum. Then we have to proceed from the left towards the right. In A3 you can see it is 10 max, in A24 it is 35 max, in A2 it is 35 max, likewise, right. So, the data what we have, right, so where it fits, that becomes the group, right. So, I have taken an example of the percentage passing 75 micron is 40. In this you can see it is not fitting from A1 to A2. In A4 you can observe the percentage passing is 36 minimum, right. So, our soil will be falling in a group A4, A5, A6 and A7, right. So, we do not know exactly which group it is, right. So, for that we have to make use of the other datas like liquid limit, plasticity index as well as the group index, and whatever the liquid limit value we have, right. So, we have to check in only A4 to A7. Why? Because already we have eliminated A1, A2 and A3, that is why we have to check only with A4 to A7. Similarly, the plasticity index is also checked with A4 to A7, and finally we will be getting some groups either A4, A5 or A6, A7, and you can see on the bottom the general rating as a subgrade, right. So, in that usually A1, A2 and A3 are the materials we prefer to use it in a subgrade, and A4, A5, A6 and A7 which consist predominantly of silt and clay materials, which is not to be used in the construction of subgrade, and that is why it is given the rating of fair to poor. And this is how we can classify the soil under HRB system of classification. Thank you.